Hello, everyone. Track number 2. I hope probably you're a little bit bored of all the large language model. Now you want to hear what's with this data, the data mess, the data disaster. So this is here the right talk. Our next guest on stage, she just flew in from Berlin for this amazing conference here in Zurich. And she is the lead data scientist at Yelp, and as well she's a HB Data Science Ambassador. You can ask her in the break, what does that mean exactly? She will tell us a really nice story. It will be a story about how to avoid the data disaster. In her free time, or what's really on her heart mission is combat biases in data set. And she tries to really everything she can do with AI to help the climate exchange. Welcome with me on stage, Samantha Edds.
Hi everyone, I'm Sam Edds. I'm a Z by HP Global Data Science Ambassador, and I'm also a lead data scientist at Yelp. And today I'll be talking about explainable AI, how simplicity is complicated, and 6 concrete steps that you or anybody can take to avoid an AI or data disaster. Tell me a story about puppies. Predict the ad revenue for an ongoing campaign. Predict whether employees are exhibiting high morale or psychological safety using Slack messages. Predict whether somebody in a mugshot is the same person caught on camera committing a crime, except not in the EU. All of these stories, all of these predictions are made by fitting a model to some data. And we know that all models are wrong. The real question is just how wrong are they? This could be the difference between thinking that your employees are exhibiting high morale when they say something about a good day, but really they're unhappy and about to leave the company. Or this could be the difference between somebody getting arrested or not. Again, thanks to the EU Act, not here. Data is changing our lives big and small, both in our workplaces and more in our everyday lives. Yet, in the news cycles, we're constantly seeing stories of different AI disasters, from small startups to Amazon's hiring algorithm to HireView's facial recognition software. And why is that? I would say that most of these AI or data disasters are actually quite preventable, and that's how this talk came about, is 6 concrete steps that one can take to avoid such situations. And I say this as someone who has uncovered multiple data disasters at companies, and also been a part of one. So let's get into it. Step 1, use a subject matter expert. As a data scientist, I have worked in 8 different industries: consumer packaged goods, crime research, education research. Let's see, I'm running out. Crime research, education research, individual legal rights in Germany, advertising, technology, and there's one that I am forgetting. Clearly, I'm not an expert in any of these fields, but I'm able to go down deep enough and really understand a lot of what is going on in the relevant fields. But sometimes the data will look correct to me, but there's just some context that I'm missing and can't see. And this is where a subject matter expert comes into play. They can help you understand what is this context that the data really can't tell you alone. And so I think it's super important to have a subject matter expert as early as possible in your processes. Let me give you an example from my past. At the end of my first week living in Berlin, my first week living in Germany, I knew 0 people, and I uncovered a data disaster that led to the main and only product of the company being shut down, and also later led to most of the company, myself included, getting laid off. So what happened? This company was using Slack messages to try to predict psychological indicators such as high morale or psychological safety. And the labeled data set that the company had was made by a few people, and none of them had a particularly strong psychology background. And they used a STEM dictionary. So they took the stems of words, and then it was going to be applied to many different words and phrases that had absolutely nothing to do with the psychological indicators that they wanted to predict. Clearly, I did not know this before joining. When I joined and looked underneath at the labeled data, it was very clear to me that this made absolutely no sense. And the company had recently hired a psychologist, so the two of us had the entire company spend 2 days labeling data. And we very quickly found out that it was actually extremely hard to label these kind of concepts. A lot of times you needed more than just one message. You needed a series of messages, or you could have multiple indicators within a message that were very conflicting. So it helped us very quickly understand, is this product actually viable or not? And many of your use cases will not have such complex material, but I think it still shows that a subject matter expert is very important to have and can help fill the gaps and save a lot of time and pain for everybody. Moving on to step 2, consider bias prior to data collection. One of my grad student professors eloquently put it, garbage in, garbage out. It doesn't matter with which model you fit the data. If the data underneath are biased, this is going to perpetuate through to your end result, and your end result will be biased. So this is super important to take into account as early as possible, and if you're not labeling your own data, to go back and figure out what happens when it was labeled and how it will be. Going back to the example of the company where I got most people laid off, they had 2 major problems with their data collection process. The first was obviously the labeled data, using a STEM dictionary that's going to take the root of words and then match to many words and phrases that have nothing to do with the psychological indicators. The second issue was the training data. GDPR went into effect when the company was quite young, and as a result, they ended up with only about 500,000 labeled examples in English, which were from a few clients in a very small number of geographic areas. Yet the clients that the company was trying to reach were generally bigger companies, so they probably use Slack quite differently than a very small startup where you put everything on Slack. They were in a number of other geographic areas as well, so we would think the colloquial language could be quite different. And they were also in a number of different business areas, so the business language was different. So their training set was really not representative of the group that they were trying to predict on and the clients that they were trying to work with. So always remember, look, I think this crowd knows this already. Consider bias prior to data collection or use a looking back approach. Going to step 3 now. Check all the steps in your process for bias. This means even in your cleaning step, is there something that you're doing that are excluding certain groups? Which might be okay, you just always want to note this as well. Or are you including or excluding certain variables? And when I worked in crime research, something that I often saw was that organizations would leave out race as a variable so they could say that they did not include race. Yet, this is in Chicago, and there's a problem with this because zip code or low-level geographic variables were essentially a very close to perfect proxy for race. Chicago is a very segregated city, and so even if you left race out, it was effectively as if the race variable was still included in the modeling. And then when they went to report the results, something that I noticed is they often left the results at a very high level. So the averages and the medians that they were reporting were not really telling the whole story. If you had reported out the results at a lower level, so including this lower level geographic variable or zip code, you would see something quite different. But they're essentially, in some ways, kind of hiding results as well. So just remember to always check each step of your pipeline for potential bias, both in the statistical sense and in the general sense of the word, because it will always be seen in your end result. Moving on to step 4. Predict on values that your model is trained on. We all know here that models are not magic, they are based on historical data. And you can always get a result from whatever model. You can train on one thing, predict on something completely different, as long as you have the variables formed in the same way, and it will literally pass through and not break something, which is both the good and also scary thing. But it's super important to predict on values that your model is trained on or within similar ranges, because otherwise you don't know if the results you get is going to be reliable or not, or how it was formed. So one example that I've seen is, say that you want to predict the rent for a 2-bedroom flat if someone is paying too much rent for a 2-bedroom flat or 2-room flat in Berlin. Your training data set has somewhere between values for rent between 550 and 1,500 euro. So clearly not in Switzerland. And the value, though, that you want to predict on, you want to see this person comes in with a flat that costs 300 euro a month. And you want to see, is this person paying too much rent? There are probably a number of inherent differences, like why this 300 euro is so much less than the 550 to 1,500 range. In this case, it's probably the person has a very old rental contract, and there may be some other inherent differences in this process. And so it's super important to consider, I would get an answer from the model, but because the data are underlying inherently different than what I trained on, I would not necessarily want to use this model and take that answer. Moving on to step 5, look beyond the model metrics and consider your average use case across your different groups of interest. So I actually think that improving modeling metrics can be a bit like Mario Kart. So hear me out on this. You're driving along very fast, you see a gold star ahead, you hit this gold star, great, you get a 90% F1 score. Then you see another star ahead and you're like, yep, I can definitely get this. So you speed up, you also hit this star, 95% F1 score, you are feeling very good right now. And then you see a star in the corner up ahead of a tight curve. And you think, I can still do this. I've got this. You speed ahead, and then suddenly you hit a banana peel. And your cart starts to spin out, you're revving the engine, and you're trying to move forward, but you're just not getting anywhere. And this is when Mario Kart can feel like improving modeling metrics. And I, myself included, and I think many other data scientists know the pain of this process. Sometimes you lose sight of the larger context, which is slightly improving the modeling metrics is not going to make a difference in the broader reality of things. I used to work in education research, and one of the things that we worked on was trying to predict whether students would drop out of what the US calls high school, so the 9th through the 12th classes. And we used data at the beginning of the 7th class because we wanted to make sure that an intervention could be given while the student was still quite young. And we had some pretty good results, but I thought, we could just do a little bit better. And I lost sight of the broader context, which is, even if I could correctly predict that a few more students were going to drop out of high school, it wouldn't actually matter because I couldn't provide an answer that said, there are 100 schools and 100 different students. Maybe I could go to 5 schools and reach 20 students at each school. But I could not go and say, we should go, here are the top 100 risk students, let's go to these 100 different schools. So I really needed to focus on the average use case, which in this scenario was the school level, and think about the concentration. What is the concentration of students at each school, and then figure out, okay, which have the relatively highest ones that we can actually work with, and then begin that process. So it's super easy to get caught up in improving modeling metrics because you think, 95%, this is pretty good, but what if I can just do a little better? And so it's really important to keep in mind the reality of whatever your situation is, because you can probably end up saving yourself some pain and time by doing this as well. So now we'll move on to step 6. Examine your edge cases. This will help you understand the limitations of your modeling and also understand and potentially uncover biases. And this example is not from my work, but is from a project that I greatly admire. There's a project called Gender Shades that was made by the MIT Media Lab. And they set out to look at the facial recognition AI services from IBM, Microsoft, and Face++, and to evaluate them. And all of these models had somewhere in the middle 90% accuracy, but these models were mostly trained and tested on white males, with a small number of white females and very few non-white people. These algorithms are used for anything from airport security screening to law enforcement surveillance, which is also why I'm very glad that there is the EU Act, and that will not be possible in many other places. But in the US, these are used for law enforcement surveillance. And you can see in the errors tell the bigger story. 95% of Microsoft's algorithm, and obviously since then they have changed these algorithms, 95% of the errors in Microsoft's algorithms were people with darker skin. And 93% of people that Face++ misclassified were women. And examining your edge case really matters, and truly looking at your full pipeline and getting different people in the room to try to understand different perspectives and see what could my edge cases be, and to examine them is very helpful, particularly if you do anything dealing with humans, but dealing with any kind of data, it's super important to do and to not lose sight of, because like I said, any giant company, small company can do that. And so with that, I will just go through our 6 steps once again. Step 1, use a subject matter expert. 2, consider bias prior to data collection. 3, check all the steps in your data pipeline process for bias. 4, predict on values your model is trained on. 5, look beyond your model metrics to your average use cases. And 6, examine your edge cases. And with that, I'm happy to answer any questions. Thank you.
Thank you very much, Samantha. I can assume there will be some questions from the audience. Is someone a question? Data disaster unknown in your company?
It's never happened to anyone else, just me. I only work at those places.
6 steps, but there were mainly 6 problems. How should you start? So what would you give as an advice to a company or a beginner in this field? Where should they pay attention? I mean, 6 topics, each of them quite a large field. Where to start? What's the most important?
I think I would say step 2 is, well, it's 2 and 3 are kind of similar, but 2 is just focusing on the data collection aspect, but it would be look very carefully at your data prior to collection and labeling. Especially if you're not labeling it yourself, then you have less control. And it's super important to try to understand what is going on, and are there potential biases that exist in the data that you've received because of the data that it's trained on? Is it missing is it going to miss out on certain groups? And that can actually be quite hard to do. So I think it's very important to have people from a wide variety of backgrounds to come up with the potential both average use cases and the edge cases to try to understand and really poke at the data to see, okay, where does it work and not work?
It's still a long journey, huh? Is there a question from the audience? If not, we have a very nice present from Switzerland, the data bottle with your name on it. Thank you very much, Samantha Edds. Thank you.